Hello, my name is Omar Aksu, and today I'll be presenting on Project Pseudocode. And what Project Pseudocode is, it's you're making your own pseudocode and you're getting an AI generated pseudocode off of matrix multiplication and simultaneous linear equations. And from there, we'll be analyzing them, comparing and contrasting them, seeing what the differences are and the similarities between the two and kind of determining which one would work best overall for this project. So starting us off with matrix multiplication, which is the pseudocode I have wrote. So we start off with start, and then going on, we inform the user of matrix A, so rows and columns, and inform the user of matrix B, rows and columns. So this is when this is stated, it's informing the user, hey, put your condition. So 3 rows, 3 columns, and do the same for matrix B, maybe 3 rows, 3 columns. But in this case, let's say your rows is for matrix A, let's say your rows is 3, and maybe your columns is 4. And for matrix B, let's say your rows is 4 and your columns is 3. Since your rows in matrix A is 4, so it's the opposite, it's going to give an error message. So when you're looking at when the column A is not equal to rows of B, give an error message. So it'll give an error message to the user and it'll tell them, hey, it's going to inform them, which is the lines given. Inform the user of matrix A, rows and columns, and inform the user of matrix B, rows and columns. So when this is given, it's a keep on giving them this error message and making them repeat themselves until they meet that condition of, hey, your row has to be equal to your columns. And then we go to, so if they meet that condition, they're going to give the matrices for A and B. So they're going to put the inputs for matrix A, and when they do, they will ask for each row in A and each column for A. So then continuing on to the next, it'll be the same thing for matrix B. It's gonna ask you to put the rows and the columns and basically your inputs for matrix B. And now the program will execute the matrix multiplication. So in order for it to do this, yes, it's gonna combine them, but it's gonna also initialize the result of the position at 0. So set the result of the row and column equal to 0. So when that is set, it's going to use a loop to compute the sums of the elements. And when it does that, it will show the result for the matrix, which is multiplied between the A and B, and it will show for the row and the results, for the column and the results, and overall display the result with the rows and columns that you have put. So going with matrix multiplication that ChatGPT wrote, so theirs is they're prompting the user to enter the rows and columns of matrix A. So then it goes to the next line, and so they put the conditions for rows A and columns A. And then they say prompt the user enters rows and columns of matrix B. So when they put their numbers for rows and columns of B, depending on the user, if their columns is not equal to their rows, it will show them a message. So for example, in input A, your matrix A, if your column, since it's a rule, if your column A is 4 and your row B is 3, it's not going to work. Then it'll display the error message which they wrote. Dimensions mismatch for multiplication. Columns of A must equal rows of B. Re-enter dimensions. So then it's going to tell the user again, hey, input your rows A and columns A, and input rows B and columns B until you fulfill the condition. Continuing on to the next. So if the conditions were meet and satisfied, it's going to end that while loop, and it's going to prompt the user to enter the elements for matrix A. So what that basically is, so it's going to tell the person to input matrix A, rows A, columns A. So whatever rows and columns that they declared, they're going to enter numbers into those columns and rows. And same thing for matrix B. So it's going to prompt the user to enter the elements for matrix B, and it's going to tell them to input matrix B, rows and columns that they declared, put numbers into that matrix. So with the next line, so it says for I from 0 to rows A to 1, for J from 0 to columns B1, result I times J is equal to 0. For K from 0 to columns A minus 1, or columns A to 1. So what this is, it's a triple nested loop. So if you're looking at the A rows A to 1, it's the outer loop of rows of A, and the middle portion is the middle loop of columns B, and the last one is the inner loop for multiplication and summation. And the result ij is now you're combining your matrix A and matrix B, so you're multiplying them together. And continuing on, it's going to end that, and then it's going to display your matrix and its resultant matrix, and it's going to display your result matrix, and it's going to completely end there, and it has completed what it had to do. When it comes to the similarities, they both begin with user inputs for the matrix dimensions. They both have a step to ensure that you are able to do the matrix multiplication. They both state to enter inputs for matrix A and B, and they both share a final result. So the differences between them, starting off with clarity, is that mine describes, the loops, the while loops in words. Rather, the structure with ChatGPT is more explicit by using IJK to define it. When it comes to syntax, mine's more casual, while ChatGPT's is more formal. When it comes to the style of it, mine is more, I guess, descriptive, while ChatGPT's it's more made, I guess, properly and formally. And then the functionality of it is that mine is just like it describes the steps, but I forgot I didn't put a function, while ChatGPT put a function. Overall, I think I'll be sticking with mine since it's simpler, it's easier to understand, kind of get an idea of what you need to do. Now we're going into the simultaneous linear equations of the pseudocode I wrote, and we start with start. So the first line is inform user to insert the inputs of the 3x3 of matrix A, and inform user to insert the inputs of the 3x1 of matrix B. Then you would need to compute the determinants of A. So you would need to create 3 copies of matrix A, define dx, dy, dz. So when you do that, so whatever data you put in that 3x3, you'll make 3 of them. And when you make that 3 of them, you'll be substituting, so going now to the next code, the line, pseudocode, substitute first column of dx with inputs from matrix B. So your first column is going to be substituted for your matrix B. And then you do the same thing for the second and third. So substitute second column of dy with inputs from matrix B. Substitute third column of dz with inputs from matrix B. So now, since you did all that, you would need to compute the determinants of matrices of dx, dy, and dz. Moving on to the next slide. So once you compute the determinants of dx, dy, and the z, we would use Cramer's rule. And Cramer's rule is basically whatever you compute for dx, it's going to be divided by the factor of a. So it's the same for your y and your z. So calculate x by dividing determinant dx by the factor a. Calculate y by dividing the determinant by dy by the factor a. Calculate z by dividing the determinant dz by the factor a. And then it'll show the calculated values of x, y, and z, and then the code ends there. Looking at ChatGPT's version of simultaneous linear equations, so they start off with a function, so solve equations Cramer. So the first thing they do is prompt user. So they say enter a 3 by 3 coefficient of equations matrix A. So they tell the user input matrix A 3 by 3. So the person is putting or declaring the numbers into that 3 by 3 matrix. And then once they do that, it'll prompt the user again saying enter constants of matrix B 3 by 1. So now it's going to give the user the option to input the matrix B, which is the 3 by 1. So they'll put the numbers that they want in there. So then when it comes to the determinants, so if your determinant A is equal to 0, then there's really no unique solution, and I believe it's considered an edge case. Then it displays, so since there's no unique solution, yeah, so the display system has no unique solution, and it'll return and if, and then it'll say so then it'll say replace I with, matrix B if I'm not mistaken, and then you'll compute the determinant of the temp matrix. So when it does that, it would then find your determinants. So replace column I of temp matrix with matrix B, determines I, which is equal to find determinants of temp matrix. So it's going to find your determinants of that problem, and then it's going to end the case there. And then now it's going to find your solutions of X, Y, and Z. So then it's going to use the determinants of your dx, dy, dz, and it's going to divide it by the determinant of A. And when it does do that, it's going to display your solutions, which is display X, display Y, and display Z, and it ends the function there. So similarities between them, it both computes a determinant of matrix A. They both calculate using Cramer's rule. It computes modified matrices and creates the modified matrices. The differences I saw within them is that how they handled the matrices, the variables, syntax, checking for 0, and function, since I didn't add a function. Overall, when it comes to comparing the both of them and picking which one I would use, I think I will stick with the one I created, since it's, like I said with the last one, it's easier for me to understand, and it's probably will be easier for me to implement it later on when it comes to creating the code and give me an idea of what to do from there. And that is the end. Thank you for listening.